Attention car shoppers. Right now at South Carolina Federal Credit Union, you can get a new or used auto loan and pay nothing until 2024, and no payments for 90 days means nothing out of pocket going into the new year. Plus, we have flexible rates and terms, so you could make the best financial choice for you. Learn more at scfederal.org/auto loans. That's scfederal.org/auto loans. Certain restrictions apply. Existing South Carolina Federal credit loans are excluded.
This is SpaceTime Series 26, Episode 135, for broadcast on the 10th of November 2023. Coming up on SpaceTime, mineral salts and organic compounds discovered on the solar system's largest moon, Ganymede. A new space technology deal reached between Australia and the United States, and a new Russian space station to fly within 4 years. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Juno spacecraft has discovered mineral salts and organic compounds bubbling to the surface on the solar system's largest moon, Ganymede. The findings, reported in the journal Nature Astronomy, will help scientists better understand the origins of the giant Jovian moon and the composition of its subsurface ocean. The detection was made by GIRAM, Juno's Jovian Infrared Auroral Mapper spectrometer. Ganymede isn't just the biggest moon orbiting Jupiter, it's larger than the planet Mercury. And it's long been of interest to scientists due to its vast internal ocean of water hidden beneath its icy crust. Previous spectroscopic observations by NASA's Galileo spacecraft, the Hubble Space Telescope and the European Southern Observatory's Very Large Telescope have all hinted at the presence of salts and organics, but the spatial resolution of these observations was simply too low to make a confirmed determination. But when Juno flew over Ganymede, passing just 1,046 kilometres above its icy surface, GIRAM was able to acquire infrared images and spectra which have now confirmed the presence of mineral salts and organic compounds. It allowed Juno scientists to detect and analyse the unique chemical signatures in the spectral data, highlighting non-water ice materials including hydrated sodium chloride, ammonium chloride, sodium bicarbonate, and possibly aliphatic aldehydes. The presence of ammoniated salts suggests that Ganymede may have accumulated materials cold enough to condense ammonia during its formation, and carbonated salts could be the remnants of carbon dioxide-rich ices. Previous modelling of Ganymede's magnetic fields determined the moon's equatorial region, up to a latitude of about 40 degrees, is shielded from the energetic electron and heavy ion bombardment caused by Jupiter's hellish magnetic field. See, the presence of such particle fluxes are well known to have a negative impact on salts and organics. But during its June 2021 flyby, Juno's GIRAM covered a narrow range of latitudes, 10 degrees north to 30 degrees north, and a broader range of longitudes, minus 35 degrees east to 40 degrees east, in the Jupiter-facing hemisphere. Juno's principal investigator, Scott Bolton from the Southwest Research Institute in San Antonio, Texas, says scientists found the greatest abundance of salts and organics in the dark and bright terrains at latitudes protected by the magnetic field. This suggests there are remnants of a deep ocean brine that reached all the way to the surface of this frozen world. Of course, Ganymede isn't the only Jovian moon that Juno's flown past. The moon Europa, which harbours a global subsurface ocean under its icy crust, has also come under Juno's gaze, first in October 2021, then again in September 2022. And now Io is receiving the Juno flyby treatment. Its next close approach to the volcano-festooned moon is scheduled for December the 30th, when the spacecraft will come within 1,500 kilometres of Io's surface. We'll keep you informed. This is SpaceTime. Still to come, a new space deal reached between Australia and the United States, and a new Russian space station slated for launch in 4 years' time. All that and more still to come on SpaceTime. The United States and Australia have signed a new bilateral technology safeguards agreement, providing the legal framework for American commercial space vehicles to launch from Australian soil. The White House says the deal protects sensitive US technology and data in Australia, consistent with non-proliferation treaty goals. NASA have been launching rockets from Australia for years. Now, private American companies will also have access to more high-quality launch sites, allowing them to increase their frequency of operations. They'll be closer to the equator, where the Earth spins its fastest, and so their rockets will gain an extra boost using less fuel to lift the same amount of payload. Of course, back in the 1960s, the Woomera rocket range in outback South Australia was the second busiest spaceport in the world, beaten only by Cape Canaveral. But successive Australian governments on both sides of the aisle, lacking vision and seeing only as far as the next election, squandered that unique technological heritage, condemning the nation to be nothing more than an insignificant minor player. The creation of the Australian Space Agency and the injection of funding by the previous coalition government provided a glimmer of hope that a turnaround had finally arrived. The hope was that Australia could ultimately claim a share of the global space economy, which this year alone is valued at over $468 billion and is expected to pass $737 billion within a decade, according to Euroconsult. However, a series of funding cuts by the Albanese government appears once again to be dampening that horizon. As to what happens next, only time will tell. This is SpaceTime. Still to come, a new Russian space station to fly in 4 years' time, and the constellation of the winged horse Pegasus, the giant galaxy M31 Andromeda barreling towards us, and 3 meteor showers in the 1 month are among the highlights of the November night skies on Skywatch. Russian President Vladimir Putin says the first module of the Kremlin's new space station should now be in orbit by 2027. Built by Energia, the module will form the basis of a new independent Russian space station, which was slated for launch next year but suffered a series of ongoing setbacks. Russia's been announcing its intention to withdraw from the International Space Station on several occasions ever since Western sanctions were imposed following Moscow's invasion of Ukraine. Putin says the aim now is for there to be no gaps, for the work to keep pace with the depletion of the International Space Station over the next few years and the uptake of operations by the new Russian space station. The Russian Federal Space Agency Roscosmos says the new Russian orbital station, or ROS, will be placed into a polar orbit and have several innovative and unique features. For example, it'll be designed for the rapid swapping of modules, with critical modules replaced as needed to continually extend the life of the space station indefinitely. Russia's also planning a very powerful and stable power supply module for ROS, specially designed to support the next generation of research. Many of the new station's modules will detach and orbit independently for extended periods of time before redocking later. The Russian space industry, once the pride of the Soviet Union, has been suffering funding problems, corruption scandals, and growing concerns over equipment reliability. NASA plans to keep its half of the International Space Station operational until at least 2030. And despite the earlier threats to withdraw next year, Moscow now says it'll remain committed to the current International Space Station until at least 2028. This is SpaceTime. Time now to turn our eyes to the skies and check out the celestial sphere for November on Skywatch. November is the 11th and penultimate month of the year in both the Julian and Gregorian calendars. It retained its name from the Latin Novem meaning 9 when January and February were added to the Roman calendar. High in the northern skies of November, you'll find the constellation Pegasus, the Mesopotamian Etruscan mythological winged horse who was born from the blood of Medusa the Gorgon after she was slain by Perseus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, located some 690 light-years away. A light-year is about 10 trillion kilometres, the distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum and the ultimate speed limit of the universe. Astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, spectral type K orange stars, and the coolest and least massive stars of all are the spectral type M red stars. Each spectral classification is further subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest. And then a Roman numeral is added to the end of all that to represent luminosity. Now, put all that together and a star like our Sun is known as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smaller spectral type M red dwarf stars, which are about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As for Epsilon Pegasi, well, it's estimated to have about 12 times the mass of our Sun and about 185 times the Sun's radius. Epsilon Pegasi, together with the stars Markab, Al-Janib, Steat and Alpha Andromedae, form the asterism or pattern of stars known as the Great Square of Pegasus, a bunch of bright naked-eye stars shaped like a huge square in the sky. One of the stars in the constellation is 51 Pegasi, which was the first main sequence star beyond our Sun to be discovered to host a planet. 51 Pegasi is a Sun-like star located 50.45 light-years away. Its planet, or more accurately exoplanet, meaning extrasolar planet, is designated 51 Pegasi b. The exoplanet's discovery was announced on October 6, 1995 in the journal Nature. It was detected using the radial velocity or so-called wobble method with a spectroscope used to detect very slight but regular Doppler shift changes in the star's spectral lines caused by the gravitational pull of the planet pulling the star one way and then the other as the planet orbits around it. 51 Pegasi b is about half the mass of Jupiter and orbits around its host star every 4 Earth days at a distance of just 7 million kilometres. At the time, a gas giant orbiting so closely around the star was something that had never been seen before, and this led to the creation of a new category of planets known as hot Jupiters, a category of gas giants thought to have formed further out from their host stars beyond the so-called snow line, but which then migrated inwards towards their current positions. The discovery led to the realization that the gas giants of our solar system, Jupiter and Saturn, also migrated inwards closer to the Sun during their early formation, something which explains many of the features of our own solar system, including the late heavy bombardment, the asteroid belt, and some unique characteristics of the ice giants Neptune and Uranus, as well as the mass distribution of the 4 inner terrestrial worlds, Mercury, Venus, Earth and Mars. Also visible in Pegasus is the M15 or NGC 7078 globular cluster, which is located about 33,600 light-years away. Globular clusters are tight spheres containing thousands to millions of stars, all originally formed at the same time in the same molecular gas and dust cloud. Many are thought to be the cause of small galaxies that have been cannibalized by larger ones. Our own Milky Way galaxy contains at least 150 globular clusters. M15 is estimated to be around 12 billion years old, making it one of the oldest known globular clusters. And it contains an estimated 100,000 stars, making it one of the most densely packed globular clusters in the Milky Way galaxy. Its core has undergone a contraction known as core collapse, and it has a central density cusp with an enormous number of stars which appear to be surrounding what may well be a central black hole. M15 also contains at least 112 variable stars, 8 pulsars, including one double neutron star system, and the first ever planetary nebula found in a globular cluster. Now, if you're away from city lights, you may notice a fuzzy patch in the sky right next to Pegasus. And that is the majestic giant spiral galaxy M31 Andromeda. Andromeda is the biggest galaxy in the local galactic group. It's located some 2.5 million light-years away. Estimates suggest it contains over 1 trillion stars, twice that of the Milky Way, and is some 220,000 light-years across. Now, if you can't see it too well, don't worry, it's getting closer every day. You see, the Milky Way and Andromeda galaxies are expected to collide in about 3.7 to 4.5 billion years from now, eventually merging to form what will be a new giant elliptical galaxy. Another case of galactic cannibalism in action. Now, based on current estimates, Andromeda appears to have more older stars than the Milky Way. It also appears to have far less new star production than the Milky Way producing about one new solar mass star every year. And the rate of supernovae in the Milky Way is also about double the rate of Andromeda. Andromeda is surrounded by a large and massive halo of hot gas, estimated to contain about half the mass of the stars in the galaxy. This nearly invisible halo stretches about 1 million light-years from its host galaxy. That means it reaches almost halfway out to the Milky Way. Now, using a good pair of binoculars or a small backyard telescope, you'll even get to see the dust lanes in Andromeda's spiral arms and its bright central galactic core, which contains a monster supermassive black hole. Now, located slightly to the east and south of Pegasus, you'll see the ancient constellation of Cetus, the great whale or sea monster. Beta Ceti, or Deneb Katos, is the brightest star in the constellation Cetus. It's an orange giant located about 96 light-years away. By the way, that name Deneb Katos, well, it means the whale's tail. One of the other stars in Cetus is Mira, the first variable star ever discovered. Located some 420 light-years away, Mira pulsates in brightness over a period of 332 Earth days, changing in diameter from about 400 to 500 times the diameter of the Sun. Alpha Ceti, traditionally called Menkar the Nose, is a red-hued giant star some 220 light-years away. Now, it's actually a double star system, with the secondary star 93 Ceti being a blue-white star some 440 light-years away. Another double star is Gamma Ceti, the head of the whale. The primary is a yellow star 82 light-years from Earth, while the secondary is a blue star. At 11.9 light-years away, the yellow dwarf Tau Ceti is the nearest sun-like star to the Earth other than the Sun. Okay, looking south of Cetus now, and you'll see the brilliant star Achernar, which means the river's end, as it marks the end of the river Eridanus. Eridanus is the 6th largest of the modern constellations, and the one that extends furthest in the sky from north to south. Achernar is a binary system, and the primary star Alpha Eridani actually consists of 2 stars, Alpha Eridani A and B, located some 139 light-years away. Of the 10 brightest stars in the night sky, Alpha Eridani is the hottest and bluest in colour. That's due to Achernar being a spectral type B blue main sequence star. Achernar also has an unusually rapid rotational velocity, causing it to become oblate in shape. The second star in the system is a smaller spectral type A white star, which orbits the primary at a distance of about 12 astronomical units. An astronomical unit is the average distance between the Earth and the Sun, about 150 million kilometres or just over 8 light minutes. Now, if you follow Eridanus towards the east, you'll find the constellation Orion, a familiar signpost in the southern summer and northern winter skies. To the west of Orion is the constellation Taurus the Bull, and located in Taurus is M1, the Crab Nebula. It's the remnant of a star which Chinese astronomers saw explode as a supernova back on the 4th of July in the year 1054. They recorded the sudden appearance of a new star on their sky charts at exactly the position of the Crab Nebula. Their records show the supernova appeared brighter than the planet Venus for weeks on end, before finally fading from view after about 2 years. The shockwave from the Crab Nebula's supernova explosion is continuing to blast outwards, expanding at a rate of about 5 million kilometers per hour. At the heart of the nebula is a rapidly spinning neutron star, a pulsar, rotating at some 30 pulses per second. As it rotates, it shines a beam like a lighthouse beacon sweeping across the galaxy. This beam emits radiation at all wavelengths from gamma rays and X-rays right through ultraviolet, optical and infrared, even into the radio waves. Observations indicate the pulsar is slowing down and will fall to just half its current rotational rate in the next 1,000 years. November is also a great time to check out the Pleiades or Seven Sisters, one of the nearest open star clusters to Earth. Also known as M45, the Pleiades are located in the constellation Taurus the Bull and are composed mostly of hot blue-white stars. Now, depending on whose measurements you prefer, the Pleiades are somewhere between 118 and 137 parsecs away, a parsec being around 3.26 light years. The amazing thing about the Pleiades is that different cultures from vastly different parts of Earth have all described the Pleiades in the same way, as 7 women or 7 sisters. And this could possibly be some sort of ancient throwback to early human out-of-Africa civilization. Just like October, November sees 3 meteor showers. There's the November Orionids, the Taurids and the Leonids. Although peaking in late October, the Orionids are continuing to sprinkle down during the start of November, and are usually at their best during the wee small hours before dawn. They're generated by the debris trail left behind by the comet Halley, and appear to radiate out from the direction of the constellation Orion the Hunter. The Taurids' meteor shower are generated by the comet Encke, and as their name suggests, they appear to radiate out from the constellation Taurus the Bull. Encke and the Taurids are believed to be the remnants of a large comet which disintegrated between 20 and 30,000 years ago, breaking into several pieces and releasing material both by normal cometary ablation and also occasionally by close gravitational encounters with the Earth and other planets. In fact, the cometary stream of material left by Encke is the largest in the inner solar system. Being so spread out, the Earth takes several weeks to pass through it, causing an extended period of meteor activity compared to the much smaller periods of activity of other meteor showers. And further gravitational interactions with Jupiter have caused the Taurids to be segmented into separate northern and southern streams. The southern Taurids usually last from around September the 25th to November the 25th, while the northern Taurids go from October the 12th to December the 2nd. But the Taurids do have their downside. They're quite diffuse, usually only producing about 7 meteors an hour. However, they are composed of more massive material. Think of pebbles instead of dust grains. And so they tend to produce a high percentage of very bright meteors known as fireballs, produced as larger meteoroids burn through the atmosphere. The southern Taurids put on their best show just after midnight on November the 5th. Finally, there's the Leonids meteor shower, which will peak on November the 18th. The Leonids are usually pretty reliable with 15 meteors an hour. However, they have been known to occasionally produce spectacular meteor storms, with showers in 1999, 2001 and 2002 producing an amazing 3,000 Leonids meteors an hour. Even more spectacular was the Leonids meteor shower of 1966, which generated thousands of meteors per minute, falling like illuminated rain. The Leonids are usually picked up after midnight, with peaks occurring just before dawn. They're produced by the debris stream from the comet Tempel-Tuttle. And as their name suggests, the Leonids radiate out from the constellation Leo the Lion. The Leonids are a fast-moving stream, which encounters the path of Earth at 72 kilometers per second. Larger Leonids, which are about 10 millimeters across, can have a mass of half a gram and are renowned for generating bright meteors. Scientists estimate the annual Leonids meteor shower deposits between 12 and 13 tons of particles across the planet every year. Australian astronomy and science writer Jonathan Nally joins us now to check out the rest of the November night skies on Skywatch.
G'day, Stuart. Well, yes, it's November, so for us down in the south where I live, it's heading towards summer, and that means nice warm weather, and the skies are beautiful and bright, and we've got some magnificent constellations up. One problem with it is that we have daylight saving, which means that the clocks are changed, so the sky gets darker later in the night, so you've got to sort of stay up later for it to get dark. But anyway, and the nights are shorter, of course, as well, because it's coming into summer. Our friends up in the north, of course, coming into winter, so they've got the other opposite advantages and disadvantages. It goes around all the time. But lots of stuff to see. So let's start with what we can see in the mid-evening sky. So once the sky is dark, we can see the tail and the stinger part of the constellation Scorpius sticking up from the western horizon, sticking up into the sky, but only for a short time. So it's going to set very soon. Sagittarius is a bit high. It's nearby. And when we're looking in that direction, of course, we're looking towards the centre of our Milky Way galaxy. It's nothing to do with Sagittarius as such. It's just that's where that constellation is in the sky. And when we look into there, we're looking into the star fields of the Milky Way galaxy. To the naked eye and everything, you can't see the centre of the galaxy because there are too many stars in the way. But of course, astronomers have, with their big telescopes and filters and things, they've been able to look right into the centre and see the big black hole that's there and stuff orbiting around the black hole. So it's really quite fascinating when you look at that part of the sky. Even though you can't see it, you know what's there. It's just brilliant as far as I'm concerned, particularly if you can get out in the countryside where the skies are a bit darker and then you really see the Milky Way. It is really quite glorious. So up in the northern half of the sky looks fairly bare actually, and it's filled with a big bunch of constellations that have very few bright stars. I'm talking constellations like Pegasus, which is the winged horse. You've got Pisces, the fish. You've got one called Cetus, which is the whale. You've got Aries, the ram. And there's another one called Eridanus, the river, which is a big, long constellation that stretches from the northern sky down to the southern sky. It's the sixth largest constellation by area, but it's quite long and thin in places. And it's the constellation that stretches farthest north and farthest south. It's really quite long. And it's nothing really spectacular, and there's not a lot in there to see, but it's just one of these constellations they made up a long, long time ago. People are familiar with the zodiac-type constellations, Taurus and Aries and Pisces and that sort of thing. But there are actually 88 constellations up there, 88 official ones. So there are plenty of other things to see in the sky. Now, over in the eastern part of the sky, around about 9:30 p.m., we start to see the constellation Orion poking its head above the horizon. This is the sign that summer is approaching for the southern hemisphere, or winter in the northern half of the planet. When you see Orion starting to make an appearance in the late evening, you know you're heading towards the end of the year. Now, if you're trying to find the Southern Cross, that's the other thing that people like to see all the time, particularly visitors from the northern hemisphere. They come down here and they say, where's the Southern Cross? This time of the year, it's a little difficult to see. So if you can't spot it, don't worry, you're not going blind or anything like that. During the evening hours of this time of the year, the cross is upside down and either very low on the southern horizon for some people or even hidden below the horizon for others. Where I am, if I had a perfectly clear horizon without the houses across the street there, so it was just a bare horizon, when the Southern Cross is down at its lowest, I would see half of it cut off. I'd only see half of it sticking up above the horizon. So you do need to be fairly far south this time of the year if you want to see it in the evening time. But if you're staying up after midnight, if you're out late or whatever, or if you're getting up early in the morning, by then the Earth will have turned and you will see the Southern Cross. It'll be sort of to the south-southeast and lying on its left-hand side. Now, by about 3 a.m., the sky has changed quite a lot as the Earth has rotated, and it's brought new constellations into view over in the east. Orion is really quite high now in the northern sky, as seen from the southern hemisphere. You've got the constellation Canis Major with its bright star Sirius, the brightest star in the sky. It's high overhead for people who live in my part of the world. And you've got Gemini and Leo and Cancer visible up in the northern half of the sky, and lots of great things to see in there if you've got a pair of binoculars or a small telescope. Now, looking at the planets, taking them in order, we've got Mercury. Mercury's back on the scene. It was out of view last month. You'll find it not far above the western horizon after sunset. So once the sun's gone down and the sky's starting to get dark, you'll see what looks like a pretty bright, intense-looking small star. And that'll be Mercury. Now, Saturn is very easy to see in the evening sky as well. It's actually close to overhead pretty much after sunset from the mid-southern latitudes. Just look up and you'll see this fairly bright thing that looks like a star, but it's actually Saturn. It's got a slightly yellowish tinge to it. Mars is out of view at the moment because it's around the other side of the sun, so it's lost in the solar glare. And it'll take a few months to come back. It's not going to really come back into view until January, when it will appear in the morning sky out to the east before the sun rises. Out there right now in the east before the sun rises, you can see Venus. It's rising around about 4 a.m. It's big and it's bright and you really can't miss it. So if you're up early to go to work or you just had an all-nighter or something, you're around about 4 o'clock or 5 o'clock in the morning, look to the east and you'll see this big, bright, white star-looking thing.
Yes, it's not a flying saucer. It is Venus, the planet.
It causes it's the cause of a lot of reports of UFOs and things because most people don't look up. Most people don't look at the sky, and then suddenly when they do, they think, "What's that big bright white light? That wasn't there yesterday." Of course it was, they just weren't looking yesterday. And they think, gee, that's big and bright, and it doesn't seem to be moving. Oh, gee, that must be a UFO or something. But no, it's just Venus. Finally, the planet of the moment is Jupiter, because Jupiter reaches opposition this month. Opposition is when one of the outer planets and the Sun are opposite each other in the sky as seen from Earth, right? So they're 180 degrees apart. And what this means is that when the Sun is setting in the west, the planet is rising in the east, as we see it. And we therefore have the whole night to study it or observe it, take a look at it. Opposition is also roughly when any particular planet of the outer planets, Jupiter in this case, is closest to the Earth, which means that it's biggest and brightest when it's viewed through a telescope. So go outside, wait until the sun has gone down in the west, and give it a little while, half an hour or so, before Jupiter to come up rising above the eastern horizon and clear any trees or buildings that might be in the way. And there it'll be a big, bright, white star-looking thing, but it's actually Jupiter. If you have a pair of binoculars or a small telescope, you can even see some of its moons. There are 4 bright moons, the Galilean moons, the ones that were spotted by Galileo himself, and you can actually see them as little tiny points of light just with a normal pair of binoculars or a small telescope. And the great thing about them is that they orbit the planet so rapidly that if you were to, say, have a look at them at 7 o'clock in the evening, and then if you got up early the next morning, went and had a look again, they'll have all moved. And certainly by the next day, they'll have moved around. And the next day after that, they'll have moved around again because they're all going at different speeds. Sometimes you'll see 2 on one side of the planet and 2 on the other side. Sometimes you'll see 3 on one side and 1 on the other. Sometimes you might only see 3 because the 4th one is around behind Jupiter and it's in its shadow. So it's really fun to go out and have a look and just follow the course of these little moons going around. Not little moons, actually, some of them are quite big, going around Jupiter. It really is quite incredible when you can think you can see this just with a normal pair of binoculars, 7x50s or something, or even a small telescope. So if you've got the chance to do it, please go out and have a look.
That's Australian astronomy and science writer Jonathan Nally, and this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details. And if you want more Space Time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to spacetimewithstuartgary.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGary on Twitter, @SpaceTimeWithStuartGary on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.